Hello everyone, welcome to my YouTube channel. I am Syed Irfan, studying Electronics and Communication in Sri Venkateswara College of Engineering. Today we have a very electrifying topic to discuss upon, which is half-wave rectifier and a full-wave rectifier. Have you ever imagined how does these rectifiers work? How does these electrical signals get transformed into something which is very useful? Yes, a rectifier plays a very important role in converting the alternating currents into the direct currents. Now, let us look upon and see how does this happen. Before we explore the fascinating world of rectifiers, let's take down a memory lane trip on understanding the history of rectifiers. The rectifiers were initially made a century back, and they've been developing with development in technology and the electrical signals. Initially, the rectifiers were made for converting the AC signals to DC signals. Throughout this video, I will be using AC for the alternating currents and DC for direct currents. Now, let's move on in the construction and the working principle of the rectifiers. Starting with the half-wave rectifier. As the name suggests, it only allows the half of an AC waveform to pass through, resulting with a pulsating DC output. The basic components of a half-wave rectifier includes a diode which ensures the flow of current in one direction, a load resistance to control the output. In the positive half cycle, when the diode is connected to the positive terminal of the potential, that will allow the flow of current. Whereas in the negative half cycle, it will block the current and there will be no flow of current and we will have no output. For better understanding, let's see and understand how a half-wave rectifier works through a circuit diagram of a half-wave rectifier.
As you can see in the given circuit diagram of a half-wave rectifier, diode D1 is connected to the positive potential, and this makes the circuit complete, allowing the flow of current to diode D1. The input waveform comes out of a DC pulsating output waveform. In the other hand, when the diode D1 is connected to the negative potential, it acts as an open circuit and it resists the flow of current through the diode, which results in no output DC waveform.
Imagine a water pipe with a check valve. When the water flows in the right direction, the valve allows the flow of water. But when the direction of the water is reversed, the valve breaks and closes down and there is no more flow of water. Similarly, in a rectifier, basically in a half-wave rectifier, when the voltage is positive, the flow of water is allowed. But then when the voltage is negative, the flow is restricted. Moving on to the full-wave rectifier. This takes the process a step further by allowing the flow of current in both the positive half cycle and the negative half cycle. The construction of a full-wave rectifier involves the additional components such as a transformer and an extra diode. The transformer helps in the step down of the voltage. Let us try to understand the working of a full-wave rectifier through a circuit diagram.
Now, let us consider the circuit diagram of a full-wave rectifier. The input AC is connected to the step-down transformer, which reduces the value of the voltage. The full-wave rectifier is slightly different from the half-wave rectifier, as it has two diodes, diode D1 represented in the green color, diode D2 represented in the pink color. In the positive half cycle, that is, diode D1 is forward bias and diode D2 is reverse bias. That means the diode D1 allows the flow of current through it and completes the circuit, and diode D2 restricts the flow of current. Here, diode D1 gives the output wave. Then, in the negative half cycle, here the diode D2 becomes the forward bias and diode D1 becomes reverse bias, which means the flow of current takes place to diode D2 and diode D1 restricts the flow of current, and the output wave here now is given to diode D2. The full-wave rectifier gives output, the DC pulsating output, in both forward bias and reverse bias. In forward bias, it is given through the diode D1, and in reverse bias, it is given through the diode D2.
Let's take an example of a conveyor belt. It moves in both directions. In the positive half cycle, the conveyor belt moves in one direction. In the negative half cycle, it is reversed and it moves in another direction. But it gives output in both directions. A full-wave rectifier works in similar principle.
You can see in this image how a conveyor belt works in both directions.
By understanding the rectifier's working principle, we get an idea on the widespread application of these rectifiers. Half-wave rectifiers are generally used for low power output devices such as chargers and the batteries which have low power. These are very useful for the cost and their efficiency. These are the crucial factors why half-wave rectifiers are important. On the other hand, the full-wave rectifiers find their application in higher power systems that demand more stable output of the DC output, such as the computers, the televisions, and the industrial works. And this brings us to the end of the electrifying journey to the world of the half-wave and full-wave rectifier. We hope you found this video enlightening and you found it easier to understand the working and the principle of these devices. If you have any questions or would like to explore other electrical topics, please let us know in the comment section below. And don't forget to hit that like button and subscribe the channel for the more interesting videos upcoming your way. Thank you for watching. Until next time, stay curious and keep exploring the wonders of science and technology. Until our next video, see you, sayonara.